Oh, there we go. All right, hi, good afternoon, everybody. My name is Anthony Ng, and I am going to be moderating this session on battery safety here. This is a breakout session 1.3. I'm filling in for Eric Stokes here, who's feeling a bit under the weather. But regardless, we're going to have a really great discussion here about battery storage, innovations in battery deployment, and of course, safety. So we have folks trickling in. I'm actually going to give it just another half minute or so, just to let folks kind of come back from lunch and from break here, and then we're going to get started. So we'll get started here in just a little bit. So thanks for joining us today. And just as a reminder, the session, along with all of the other sessions as part of the EPIC Symposium, is going to be recorded. And so if if you're attending this session and you want to check out the other breakout sessions at a later time, as well as if you missed the morning sessions today, you'll have a chance to view all of the sessions, including tomorrow's sessions. If you miss any of those as well, they'll be posted on the CC's website under the EPIC Symposium page here in a couple of weeks following the event. Okay, so with that, let's go ahead and get started. So as mentioned, Anthony Ng, I am a branch manager with the Energy Commission's Research and Development Division. And today I'll be moderating this breakout session, session 1.3, on improvements to battery safety or safety and battery storage. And of course, we know that storage is increasingly looked at as a really critical component of reaching California's clean energy and climate goals. The SB 100 Joint Agency report back from a couple of years ago points that we need about an 8-fold increase in battery storage deployment to help support renewable energy deployment to get to our 100% clean energy goals. And that's just on the grid side, and of course, batteries are really driving the way towards transportation electrification and also increasingly looked at to provide support for community resiliency and overall grid reliability. And so batteries have been with us for a long time now, and they're going to continue to be with us in an ever ubiquitous way. And so as storage and especially battery-based storage deployments are really looking to scale up here between now and 2030 and 2045, we need to ensure that that is done safely, so that that in addition to providing all the benefits of their technologies, that they are also safe deployments, because these are devices that we interact with on a daily basis, in our laptops, in our phones, in our cars, and in our neighborhoods. So at this panel, we're going to talk to a few of our EPIC awardees to talk through the innovations that they are developing to help improve battery safety, along with a perspective on kind of community deployment of storage technologies in a built environment. So I'd like to introduce our panelists today. So joining me today is Daniel Dumovich, Director of Strategic Initiatives at Grid Alternatives, as well as Richard Wang, CEO and founder of Cuberg, Jungwoo Lee, CTO of South8 Technologies, and Andrew Shea, CEO and co-founder of Liminal Insights. So if we could have our panelists join me on stage here, and then we can kind of start off with some introductions and some context for each of our speakers here.
Great, thank you. I'll start off with an introduction. Really happy to be on the panel here. My name is Daniel Dumovich, Director of Strategic Initiatives with Grid Alternatives. And Grid Alternatives is a nonprofit organization, and we're not a technology innovator in the manufacturing process as it relates to safety, but we are a deployer We're a doer, and we also try to be a major advocate for access for environmental justice communities, or disadvantaged communities, low-income communities, tribal communities, different ways that you can say it, but have been encouraged over the years about the commission and the state's efforts to increase access for renewable energy technologies and other technologies that serve communities that are most in need, and energy storage is paramount to that effort, including the state's climate goals and everything moving forward. And the way that safety intersects with that is a huge key piece, especially in deployment. We've been able to administer a couple of grants through the CEC, as well as other single family and multifamily programs. And safety is an enormous topic when it comes to trust within the community, and meeting the intersection of needs that we need to bring rapid deployment of these systems to critical facilities and other communities that need it the most. We also need to make sure that access to these communities is well thought of and provided, and trust is a major factor in being able to overcome barriers. Many of the communities we serve are often at edge of grid, rural, and especially when you're dealing with a critical facility, you need to be able to have serviceability and other ways to keep the system running, but also not have an overburden on the community that may not have as many options to service and knowledge of how that system operates. So being able to run something safely in an emergency with a critical facility is the utmost concern of communities that we serve. So happy to give that perspective. I'll pass it on to the next panelist. Happy to be here.
Great, thanks so much, Daniel. Let's go to Richard.
Hi, everyone. My name is Richard Wang. I'm the founder and CEO at Cuberg. So Cuberg is a next-gen battery technology company. We got started 8 years ago out of my PhD at Stanford University. We got a lot of early support from the California state government, particularly so from the CEC during critical periods in our company's early history. Today, we are based in the Bay Area in San Leandro, about 200 people, full-time employees. Doing development of next-gen battery technologies based on lithium metal anodes and advanced liquid electrolytes. And so what this means are batteries that have much, much higher energy density and power compared to best-in-class lithium-ion batteries. And we're innovating across the spectrum of technology, from materials and electrolyte level innovations through to cell design and cell manufacturing, and then through to battery modules and battery pack developments. Principally, our business is focused on high-performance segments, areas of the economy that are particularly difficult to decarbonize with lithium-ion batteries because of constraints in battery capabilities and performance and safety. And with electric aviation as our principal focus, but also with additional market segments beyond aviation and high-performance auto, and then longer-term maritime and long-haul trucking are also areas that need really true battery innovations and advancements. We were acquired 2.5 years ago by Northvolt, the Sweden-based leading gigascale battery manufacturer coming out of Europe, building out gigafactories throughout Europe, and most recently announced also with a major facility going up in Montreal. And as part of Northvolt, we serve as their advanced technology center, as well as their high-performance brand and products division. On the battery safety topic, we do not, as Cuberg, directly engage in the grid storage market, but we are serving extremely safety-conscious markets, particularly in electric aviation, and pioneering technologies across the spectrum that really have large impact on how we think about battery safety at a fundamental engineering level, and believe ultimately these will have an opportunity to broadly benefit the grid storage industry as well. Thank you.
All right, thanks, Richard. Let's go to Jungwoo.
Hey everyone, very nice to meet you. My name is Jungwoo Lee, co-founder and CTO at South Bay Technologies. And we focus on next generation battery materials, and we focus exclusively on the electrolyte of a battery system, which you can sort of think of as sort of the blood of your battery. It's the medium in which all your charge moves around, and it's very, very important from a safety perspective, because right now, these toxic flammable liquids that are used in standard lithium-ion batteries are really what drives a lot of the thermal runaway reactions and thermal propagation reactions, which is what leads to the incidents that we're all very, very concerned about. So we at South Bay are focused on replacing those materials with our new class of materials based on liquefied gases. Now, these are non-toxic, non-corrosive materials. And more importantly is we sort of spin the idea on its head, is that everyone thinks pressurized gas systems equals dangerous. What we do is say, what we harness that pressurized system and say, during abuse conditions, you can vent off your battery cells, getting rid of your electrolyte or getting rid of the blood that drives a lot of your reactions, which then shuts down the likelihood of thermal runaway, thermal propagation, or any of these incidents that people are worried about. So we're trying to basically, instead of taking an engineering solution based on either short circuits or your BMS, and say from a fundamental chemistry level, can we make battery cells safer? So we've been going strong for about 8 years as well, came up around the same time as both Cuberg and Liminal, with tremendous support from the CEC, and we're always excited to give back, because without the support, none of our hardware or materials or technology-based companies really would have gotten the traction that we believe we can have.
Great, thank you, Jungwoo. And then last, Andrew.
Cool. Thanks for having me here. Andrew Shea, co-founder and CEO of Liminal, and as Jungwoo was saying, one of probably a handful of cohorts of battery companies that started in California at about the same time. So glad to be here. And when we think about quality and safety of batteries, that's pretty much fundamental to our mission. But we take a different approach. So we're not making new battery chemistries, new battery cells, anything like that. What we do is we really say, hey, look, part of the challenge that exists in the industry is how long it takes to scale up battery cell manufacturing quickly with high quality and maintain that highest level of quality that we need for transportation and for grid storage and all these other high performance applications that Richard mentioned. And from our perspective, a lot of the challenge comes down to the fact that it's really hard to detect process defects and anomalies kind of in production. It can take days at best to sometimes even months and years, depending on the nature of the defect, to show up electrochemically through performance. And so our company is really about developing and commercializing and deploying inline inspection technologies and systems that really provide the data and the analytics that our customers need in cell manufacturing and in battery manufacturing, more broadly speaking, to be able to, again, accelerate the ramp up of high quality production and maintain the levels of reliability and quality and safety that we need for EVs and for grid storage.
Great, thank you so much. Thanks for those introductions, everybody. So we're going to dive in to some discussion questions here to just dive deeper into the topic. Just like to mention to the audience here that we will have some time reserved here at the end for some audience Q&A. So as you're listening to the discussion here, if anything strikes you, you want to follow up, have a question, please feel free to drop a question into the Q&A here, and we'll try to get to those here at the towards the end of the session. So yeah, just wanted to kind of pull on a couple of those threads here. Jungwoo talked about thermal runaway as really the main kind of propagator of fire, and I think that's kind of the biggest context. I think for the three technology companies, I think you guys touched on it a little bit, but could you just talk a little bit more detail about how your innovation, your specific technology is helping to either reduce the likelihood, due to kind of unique chemistries, or Andrew, in your situation, kind of catch those earlier on in the process, just to give the audience a little bit more of a flavor of how your specific innovation is kind of helping to reduce the likelihood and improve overall safety of batteries. So Richard, let's start with you.
Absolutely. I'll leave perhaps some of the materials and manufacturing innovations for Jungwoo and Andrew, but I'll touch really on the systems design elements of battery safety, which really is a core element of both aviation as well as grid storage, with UL regulations versus FAA regulations on battery safety. And the overall framework of a lot of these safety regulations and system design initiatives is you have to assume that at some point you will have a battery cell that perhaps either wasn't made right, or even if it was made right, perhaps used in an improper way, subjected to unknown conditions, such that one cell or multiple battery cells will catch on fire. And that is really the starting point for a safety discussion. And then from there, what if a cell catches on fire, when it catches on fire, what happens? What is the worst case? And the system engineering approach is really around how do you minimize the impact of the incident as much as possible, and also reduce the likelihood of that incident. So in terms of reducing the likelihood from a systems perspective, it's about engineering very good thermal control systems, thermal management. Temperature uniformity is one of the big predictors of battery reliability and longevity. Another key element is software innovations to really monitor health of battery cells in unique and precise ways, so you can try to predict and head off these thermal runaways from happening in the first place. And then when they do happen, it really comes down to more of a mechanical design of your battery systems. How do you ensure you have what's called propagation resistance? So if one cell goes off or multiple cells goes off, you have a way to vent away all that heat and ejecta and hot gas without spreading to the rest of your battery and ultimately taking your whole container or whole pack up in flames. Because at that point, you have a much more serious incident on your hands that becomes harder and harder to contain the bigger it is. And so we really see opportunities both at that sort of health management level, as well as on fundamental mechanical systems design to ensure that you're really robust and resilient to thermal runaway and a broad range of conditions.
Yeah, thanks, Richard. Really, really helpful context and kind of setting the bigger picture of what we're talking about. Yeah, Jungwoo, just I think you mentioned this a little bit in your introduction already, but yeah, take an opportunity to dive a little deeper about how South 8 is, how your innovation is really helping to address some of the challenges that Richard was just talking about.
Exactly. I think, yeah, Richard's explanation was tremendously beautiful in that it's true. At a systems level, you have to assume an incident will happen, right? South 8's whole approach is that we are trying to design a more robust material system where the likelihood of this incident is just by definition going to be lower because the energy in your system will be lower just by using our materials. And it's a tricky approach because, I think both Andrew's and my technology is more about mitigation. It doesn't mean our solutions are going to be 100% bulletproof. Nothing in this world with the volume of batteries going out will be incident proof, right? It's about, minimizing these things, and that's going to be a materials level, diagnostics level, and then at the systems level that comes together. Because by definition, energy cells are energy cells. A Tesla 4680 has enough energy, the equivalent energy of a hand grenade, if used improperly, or has enough energy to boil a cup of coffee, right? It depends on how you design your system and how you harness that energy. So you want to, maximize energy for your use cases, right? That's why the cells Richard is designing is so beautiful for these edge cases. But you want to ensure that all that incredibly dense energy is being used in the use cases you want to, while minimizing the likelihood of others. So it's always going to be a delicate trade-off at the systems level.
Yeah, thanks, John. Appreciate that. Yeah, Andrew.
Yeah, I guess I sort of sit in the middle between materials and systems, right? So I totally agree with what Jungwoo and Richard are saying, and it's no one effort and no one innovation is enough. It's sort of a combination and a matrix of all of these, right? It's sort of that Swiss cheese idea of like you have holes everywhere, but as long as the holes are all in different places, the risk of something bad going wrong in the field, in the home, wherever it is dramatically lower. So it's all of the above. And so for us, where we kind of sit is there are some really critical defects and process issues that happen that are really hard to detect in line right now with current methods, whether it's X-rays or using like electrical testing. And so a lot needs to happen in innovation in order to, develop new methods that can both, be sensitive to these cell defects or anomalies that we know cause issues in the field, but also be implemented, in line so that you can catch these things as early as possible. That has a whole cascade of benefits, not just for safety, but also, frankly, for costs, and cost is a big deal in terms of deployment as well. That's at the cell level, and even at the system level, right? As you're building these systems and selecting which cells you're putting into your packs, it's also really important to match like cells when you're building your larger systems, because imbalances in cells can also lead to performance issues and safety issues as well. So kind of, I guess we sort of tie what Jungwoo and the materials folks do with, the systems folks as well.
Yeah, thanks, Andrew. Really, really, really helpful. Good to see, yeah, kind of the coverage across the value chain there, and how different innovations in different sectors can really help improve the overall, product, right, that gets put out there. Turning to you, Dan, kind of switching gears a little bit, since you're coming at this from, a bit of a different perspective. Richard, Andrew, and Jungwoo were, really working on developing the materials and the systems and the inspection platforms to help improve the product, that ends up getting shipped out. But you sit on kind of the end of that process, right? Working with communities deploying these storage assets, and you mentioned it in introduction. There's this interest in storage technologies. They're really useful for microgrids, in terms of public safety power shutoffs, things like that. But there is an inherent, or not necessarily inherent, but there is this potential risk that these technologies might represent it as well. Curious if you could expand a little bit. What are you seeing from your interactions with communities, particularly disadvantaged low-income communities? How do they view these systems? You talk a lot about trust. Is there trust for storage systems? Are there kind of opportunities to help improve that trust if it's lacking a little bit, and how that can inform some of the innovations that we're working on, right?
Yeah, absolutely. Yeah, happy to share some of that perspective. And yeah, I think the trust is fragile, because I think there's not a lot of understanding, there's a lot of education, and a lot of it is pretty complex. And in a deployment situation, there could be a lot of things going on. It could be part of a construction of a complex or a critical facility, or even if it's just a retrofit, there could be also solar I mean, a lot of different layered technologies as well, especially in a microgrid architecture. But I say the onus is on whoever's representing the community or deploying in the community, the project manager, the builder, the EPC, whatnot, to really understand the technology that they're using, understand all the safety implications, and be able to communicate it with the community very well and clearly. In our case, with the EPIC grant that we were deploying, it was a vanadium redox flow battery from Infinity Energy Systems, and the main selling point there, the sold us to sell, but convinced us to consider it safety and deploy it as a not fully experimental technology, but not rapidly or not widely distributed to enough where people are familiar with the systems yet. The key part was flammability, but also kind of in both directions too, because it's actually a fire station that's being used as a critical facility, also emergency meeting point, and doing EMT dispatching, and so it fulfills a lot of functions. And so the need during a high stakes event, emergency, outage, earthquake, or fire, from the outside, as much as lack of flammability from the outside as much as inside is key. But being sure that there wouldn't be the minimized risk of anything related to that system happening at the worst possible time, that you have people gathering, that the system is being used the most during an emergency, people are gathering during an emergency, so all those stakes being raised, you can't, you have to really trust that there's not going to be an event there. There's not going to be any sort of contamination. Other features that are less in the sort of the weeds of the technology, but sort of like practical, that help lead to confidence, was things like building a robust enough concrete pad to be able to lift it up off the floodplain and deal with earthquakes better. The kind of containment systems to prevent electrolytes from leaking, and some of the redundancies there. We were convinced, but there's still a gap and a long ways to go between really understanding what that means as a project manager, as a deployer, and then working with the technology providers to help translate it into the community, and really making sure they're convinced of the benefits. But ultimately, our organization feels responsible and needs to really do homework and also understand the technology companies to the best of our ability to trust ourselves even to then offer it to a community to deploy.
Yeah, thanks, Dan. Really, really, really helpful there. Yeah, pulling on that thread a little bit, and I just saw this question come in the Q&A here, and it actually aligns with one of our kind of prepared questions. But curious if any of the panelists have thoughts about the current state of regulation. I think Richard, you mentioned UL and some of these industry standards are evolving to kind of incorporate advances in new technologies. But yeah, just curious, and kind of open question for the panel, whoever's interested in answering. Yeah, kind of where you see the state of kind of policy and regulation? Is it sufficient to cover safety? Is it too lax? You know, and kind of where there are opportunities for improvements in that realm.
I'll just touch on I believe it's UL 9540 is the key regulation for energy storage systems for grid use, which I believe was released maybe 2 or 3 years ago. So a lot of the older systems that have been deployed out there weren't necessarily designed with this in mind, but I believe all new systems of a certain size need to comply with UL 9540. And from what I've seen, the regulations actually are written in a quite sophisticated manner and with, I think, a surprisingly high level of requirements in terms of battery safety. It's considerably higher actually than what we see in the automotive world, I think because these batteries are so much bigger and the risk levels are higher, and actually getting close to what you see in the aviation industry. So I think in the grid world, actually, you know, not being an expert myself, but from what I've seen and read, it actually is at a pretty good level these days. In the aviation world, a lot of the, let's say, safety requirements come actually from the incident with the Boeing 787 Dreamliner, the battery fire on board there. And as a response, the FAA had a lot of learnings from that that ultimately went into much more sophisticated battery regulations. But what we see actually on that front is a lot of those regulations were designed for fairly small auxiliary batteries on much larger aircraft rather than true propulsion batteries that are powering the full powertrain of the aircraft. And so in the aviation space, it's coming from, of course, a position of very conservative approach, but now thinking about how do we effectively regulate full propulsion batteries, where I think regulations are still actively in development.
True. I think that the landscape is incredibly robust, as Richard alluded to, right? It's several layers of testing before a product ever enters into a consumer world space. No, cell level, system level, several repeated things. My question would actually be for Dan. Given your experience with deploying these systems, do you feel as though the testing we've done has been insufficient? Because I think you're the first one that's brought up earthquake testing. I was like, I don't even think I have to do earthquake testing for any of my system tests right now going out the door.
Well, I'll be honest, I don't know yet. It's, you know, this is really our first one. Is more just the being able to have the standards and precautions and sort of like a, you know, like installation manual and things like that clearly laid out from the beginning, so that you know, a non-technical expert who's trying to bridge that gap, you know, between the, you know, all the other stuff that goes into project deployment, you know, siting and you know, again, if you're working in a microgrid, there's other technology concerns. It's like you want to rely on the storage component to be as safe as possible, and it's just being as clear as possible so that there's confidence in the testing without understanding exactly what the testing necessarily means. Because I think that gap will exist, especially as this, you know, hopefully gets deployed more widely and rapidly. And again, even around the kind of like the serviceability and like safety in, and also could just be who is servicing it, like understand the components. So there's no risk of, you know, a community edge a grid that's rural and may not have, you know, someone that's able to roll a truck within 2 hours or something possibly. And either the system goes down or there's an issue. And so it's like, oh, I think I could just take a look at it or check it out myself. In some ways you want to build that capacity, but you got to know if that's even appropriate or where that line is, just so you don't have somebody, you know, trying to fix something that they shouldn't, but also just to make sure the systems are running longer. And again, more to the fact that like people are just going to have that gap in understanding what those test results mean. So that's where the trust comes in. Just, you know, I don't know if there's a role in the commission with that possibly, but yeah, I know that some of that through the grant process is evaluated on your grant proposal. But again, as this gets wider, hopefully wider deployed, you know, how do you make sure the layman's you know, can understand what they're reading.
And I think a lot of what we've been talking about is like government regulations and standards, and a lot of, I think, what Richard and you all have been referencing as like testing of the systems and the cells and the batteries once they're in the field. Like if there's any kind of catastrophic event, making sure that whatever is deployed can withstand that and not cause any harm to the community, which is super important. I think there's also a role to play of industry standards that I think there are some well accepted testing and qualification types of workflows, but I'm not sure that I have seen as rigorous of kind of quality standards at the industry level, like you do, for example, in the semiconductor industry. There's a whole set of like semi standards that there's no government regulation around it per se. It's just industry folks coming together and saying, we all agree that this is important and let us stick to these. I think there is definitely a role for government to play in facilitating that conversation. But I think industry can really take the lead in actually setting those standards as well.
Andrew, I want to pull on that thread a little bit because, I know in the battery space, they kind of, divide out kind of the industry. There's the tier one kind of battery providers that are like your high end, high value battery production, but then then it goes down to tier two and tier three in terms of kind of lower value, kind of less energy dense, like less complex materials. But I just to that point itself, it seems like there is opportunity there to really, no matter what tier of battery production you're doing, right? Like these are in people's homes, just because it's not in a car doesn't mean it, it can still pose risk to people, right? So can you talk, just pull on that thread a little bit about in terms of like industry standards and how that stratifies, even within the battery industry itself.
Yeah, I don't know that there's necessarily maybe Richard knows better, but I don't know that there's an agreed upon like definition of this is what it takes to be quote unquote tier one or tier two or tier three. Honestly, I think that actually was a little bit of a marketing terminology
Yeah.
that started to come out. But it's like the smell test of like, okay, tier one is like our major auto brands who are sort of known and respected for quality and performance buying cells or promising to buy cells from these companies. Okay, that's tier one. If it's tier two, it's like, are there companies that probably are safe from the product standpoint, and it just kind of stratifies that way. It's really kind of a thumb in the air thing. And so I do think that there is value in clarifying, what are some of the standards and things that need to be achieved in order for someone to get that stamp of approval of like, hey, they may only be producing 100 gigawatt hours, 1 gigawatt hour or less right now, but they actually have what it takes and are proving what it takes to actually be a commercial passenger vehicle, home storage, whatever the end product is, that level of quality, we can start to agree on like what it takes to be qualified for that. Because right now, I don't know, it seems a little ad hoc.
And there's an area sort of adjacent to home energy storage, which is other home products that are much less regulated. And these are things like, random e-bikes or scooters that you buy on Amazon, totally unregulated, tier 2, tier 3 suppliers, no quality controls. And that is driving a lot of fires. I mean, not as big as a full container of batteries going off, but at a much, much higher incident rate as well. And I think that's another area from a consumer safety perspective, where the systems are small and there isn't a lot going on from a regulatory perspective, but probably is becoming a challenging area where there are municipalities banning these things from apartment buildings, for example, because they don't trust in the battery safety. And I think as an industry, that, and from a policy perspective, that is definitely a ripe area for innovation.
It's a great point, because we all sort of realize how ubiquitous battery systems have become in our world, right? It's not just the e-bikes, like Google Nest systems, right, or thermostats, or small battery packs. I think it's tricky because it's not just a tier one cell supplier makes 100% tier one batteries. They bin them into their own systems, right? You got A cells, B cells, C cells, and the cream of the crop goes to these automotive groups, but then it all trickles down. And as a whole, this happens because one, battery manufacturing is super hard, and two, it's not very profitable. So I think in line with sort of what Andrew's alluding to, it's going to be about coming to an industry consensus as to what diagnostic techniques are we going to be using to qualify the quality of cells. Just kind of keep plugging Liminal and their inline system here as sort of the baseline system that everyone should be using.
I'm not saying that you are.
Exactly. So it's not just what Andrew's saying. I think as a whole, there is a conversation happening about what are our criteria going to be in order to, because it's in everyone's interest to get everyone's yields and quality up so that everyone can continue to produce more and more cells to drive this energy revolution.
I love the cross promotion support there. So, you know, this is the Epic Symposium, and of course, you know, our program here is really focused on research and development and developing new innovations. So, you know, looking forward, where do you see some opportunities that Epic could play a role in kind of continuing this discussion? You know, so we talked a lot about already kind of you know, lifting the overall standards that the industry as a whole can meet to try to, you know, kind of have some you know, minimum baseline that is acceptable. Like, what are some? Are there any additional kind of thoughts or considerations, you know, for the CEC, for the Epic administrators, as we think about future investments in this space? Kind of open question to any of the panelists.
I can maybe take a first stab at this. On the systems engineering front, I think one thing we see is that the level of battery module and pack design capabilities are becoming quite mature in the auto industry, not universally, but many automakers are becoming world-class at battery reliability and safety. And the grid is on the way there as well. But if you look at anything outside of those two high volume markets, the level of systems engineering and design is still at a much, much lower level. And I think it's a matter of how do you really deploy best-in-class design methodologies and capabilities, and also how do you keep innovating on how do you most effectively package battery cells into a safe system? How do you monitor them when they're in the field, looking at software algorithms, and also new diagnostic tools that can be used in the field to really understand battery safety? Because especially as you get outside of these very high volume markets where you're attracting the sort of cream of the crop of cell supply, the kind of system level thinking and diagnostics in the field become even more important to try to catch things that get through that are not, let's say, those A-grade cells being deployed in large systems.
Yeah, and just to follow on to that, I think something that I've always thought would be a really big value add is like some sort, like there's a lot of smaller scale prototyping, you know, either production lines or test beds. I think something that's truly industrial scale, both on the cell design cell side as well as the packing system testing and safety testing and all that, performance testing, all the above. I think that is an area where there is a wide open space that California state could play a really leading role in, and you see a lot of really good models of similar types of things, you know, in Europe. So I think that's a place where, you know, if California is going to be a leader in energy storage and in grid and all that, I think that's something that could be play a huge role.
True, because I think California as a whole, plus all of America, we want to be an innovation economy, right? We want to be the champions of the next greatest battery system out there, which is why you have, you know, our education systems coming with the ideas we have. We need to help bridge this tremendous valley of death where we have to learn how to take our innovative ideas to large-scale manufacturing. And that's just as a whole something America doesn't do very well. So that's going to be a tremendous investment that has to be done at some sort of government level, because no one of any of our companies will have the capital in order to do this.
I'll just add on to the sort of manufacturing focus on innovations and inspection techniques, process controls, and so forth. I mean, and certainly in Andrew's company is a good example of this. But that broad field is of particular importance when you talk about new battery companies and next-gen technologies, because these are, right now, the lithium-ion battery industry works really to a significant degree because of substantial know-how. And it's sort of companies in Japan and Korea and China that have just been making batteries for decades and have made billions of cells, and they just have people who know how to dial it in exactly. But when you build a new factory in a different country, even if you're an established manufacturer, and certainly if you're a new manufacturer, it's a totally different ballgame. And catching up on that know-how is extremely inefficient because it's very subjective. So having really precise engineering and inspection techniques that can tell you, like, actually, you know, am I actually doing this right? Not just like some guy who has 30 years of experience on the line managing this process, ultimately will let us scale new technologies and new companies much, much more effectively.
And maybe just to add again, to turn over to Dan's realm of things, like a lot of what Richard's starting to talk about is like workforce development and really bringing people and communities into this transition, you know, training installers, training deployers, training people who are running the production lines, like super important as well. And California has such good talent that we need to bring forward into the electric economy. So I think that's another great test, you know, use case for California money.
And just going
Yeah.
back to sort of thing Dan said, it's not, we're talking a lot about manufacturing. Dan also talked about deployment side, right? It's making sure that the people in the field know how to use these systems. Sorry, Dan.
No, exactly. No, that just you said it. Yeah, it's a long road too. Workforce development overall, but especially with technologies where you have to understand them to teach them, and things evolve too. I mean, one of the challenges I think was brought up in one of the earlier questions too is like how do you work with deployers or other technology partners and are they going to be around in however many years, like is the knowledge of the systems that you're maintaining going to be there, and that translates directly in workforce development. How are you able to train people? I mean, is it full electrical license, XYZ certifications are needed to even open up the hood and touch the thing? And it's like, how do you get people to get there? And if you're working with more vulnerable environmental justice communities, you're starting at a different place a lot of times. The career paths aren't necessarily like there's already people in apprenticeship programs and on their way to becoming electricians. Again, people might be coming in from very far away. So that has a lot of implications for how you're building that local capacity and knowledge. And then, you don't want to have people fly in from across the country necessarily to service something either. So how do you bridge those gaps? But yeah, I'd say back onto the sort of trends, in the deployment side, especially again, we deal with more like critical facilities, and we're venturing more into like the emergency services side. And we're seeing the two somewhat opposite, I mean, different directions, but around high mobility and rapid deployment for systems, which can, I mean, looking forward, can encompass a lot of different things. It can be even vehicle to grid in the future, present and future, other sort of portable mobile renewable systems. Things are trying to replace the massive swath of gas generators that have gone out since the PSPS or public safety power shutoffs have been commencing. Those kind of concerns around mobility and rapid deployment, and then also long duration. Those also happen to be the two EPIC grants we're managing at this point, and how they relate to the needs of the community. But yeah, long duration too is emerging as unpredictability of climate change and the sort of events that we're going to have, they're going to last longer and longer. And so building that resilience in ahead of time, fixing tomorrow's issues with today's technology or Friday's issues with Thursday's technology, that's a big challenge. So we're trying to, again, bridge those two gaps, and just provide sometimes multiple services to communities. So it's not even just deploying one type of battery, one type of system. How are they integrated and coordinated together within the community knowledge?
Yeah, thanks for that. Yeah, great discussion. Couple of questions coming in from the chat here. Actually, two questions pretty much along the same theme here, so I'll kind of combine them into one here. Curious, if anyone and any of the panelists here have some thoughts on recommendations, I guess, for local jurisdictions who are kind of at this intersection. I think kind of more on the deployment side, for especially for dense areas, like San Francisco, like the Bay Area, to help balance fire safety while promoting battery adoption. Are there kind of thoughts or recommendations that the kind of for the local implementers to for these technologies?
I think that's solidly you, Dan.
Yeah, the rest of us are just going to say, put it outside.
Can't hear Dan.
Yeah, Dan, you're on mute there if you're trying to talk.
Okay, there we go. Sorry,
Yep.
Wasn't mute button wasn't clicking. Do apologize. I was trying to hit the button there. Do you mind repeating the prompt really quick?
Yeah, so a couple of questions from the chat here. Do you have any thoughts or recommendations for local jurisdictions, looking to permit or cite these battery systems, particularly, in kind of dense urban environments? How do you balance fire safety with, promoting battery adoption?
Yeah, so in our experience, which is still relatively limited, we've not had to have too many concerns over energy density, which I know is a big one. And I'm assuming there's a lot of technical reasons for the different safety implications between dense systems or not dense systems. In our case, we had a lot of space, so we were able to use the more like container, large block, have it close enough that you're not, running a lot of cables, but also far enough where you're not, should there be anything related to the system that's not going to affect the actual, buildings and facilities and hopefully people nearby. So yeah, I'm not sure exactly what to do about the trade-offs with energy density in a place like San Francisco. One thing that we did have was navigating CEQA and other sort of environmental permits. We avoided some of it just because the facility that we were looking at was more or less brand new, or I think it was a year old. So they had a lot of updated plans. There's a lot of all the the geotech surveys and all the different ways to answer the questions around is this sited appropriately. We're already sort of present, but if that's not the case, then having a good lead time on something like CEQA would be really key. I'm sure there's others too, but luckily in our case, the permitting. Well, this is actually an interesting point to touch on because we're working with a tribal community where permitting is done within their jurisdiction. And a lot of times it's a new technology. It's not like it's easy to reference or there's something on the books about how to permit it. So there's sort of you're actually like bringing research and questions, especially related to safety, to the jurisdiction for them to evaluate, but you're also sort of helping them evaluate it too. Luckily, in our EPIC grants, we had a university partner, UC Riverside, and the CCERT department there that kind of helped with that process, just even evaluating and getting recommendations there. But yeah, that's something we always want to be really careful with. But you're actually asking a lot of times even the technology provider too to be like, what should the permitting be for this jurisdiction that hasn't written those codes yet?
Mm-hmm. Yeah, and just as you were talking, it occurred, just kind of twisting the topic on its side a little bit. Earlier in the day, the plenary session was discussing, DER deployment, and one of the speakers mentioned that your typical EV is like many times the size of a stationary storage for like a residential application. And Richard, you mentioned earlier that the kind of manufacturing standard for the grid and vehicle markets are fairly robust, in your opinion. But curious if any of the panelists have thoughts of, as vehicle deployment and that interaction with V to X, as we call it, vehicle to grid, vehicle to building, how that intersects with safety in your minds, or if there's any specific challenges with kind of deployment of vehicles in a storage setting, and how that intersection kind of comes about. So yeah, just kind of just curious if any of the panelists have any thoughts on that intersection there.
I think the reason you see auto companies being somewhat slow moving in terms of deploying vehicle to grid is because I think of unpredictability and unknowns on how this impacts battery health and longevity in their vehicles. They've engineered the vehicles primarily for fairly low utilization of passenger cars, which is for the most part really not driven that much over 10 or 20 years. But if you add on a V2G application, especially if you're looking at something like a load balancing where it's a cycle every day, that's vastly more cycles than a typical auto pack is designed for. And so it of course gets into questions of both, let's say, liability and warranties, and insurability, and ultimately, at the end of the day, also it comes to battery reliability and safety. And so, if you're cycling this thing continuously in a garage, day on day for something it wasn't necessarily designed for, that can lead to a bad outcome. So I think the automakers are being appropriately cautious for that reason, because technologically it's not that hard to just design a thing where you can hook into your grid, but they're not necessarily enabling it yet because they're still trying to understand the impacts on battery longevity. And that's really where software algorithms, predictability of batteries is really still a fairly immature area. So people are trying to get field data to understand how this really evolves.
Sounds like promising research topics there for the future, huh? Yeah, curious, Andrew or Jungwoo. Yeah, I'm just curious if you have any thoughts on kind of, vehicle to grid, vehicle to X applications and impacts on battery use or battery health.
I mean, I think Richard's correct. It's not so much. I mean, it's a safety issue in the fact that you don't want to take any battery outside of the spec in which they've been properly designed to be used, right? That's in essence the heart of what we're all been saying. I mean, theoretically, you could design auto batteries in order to meet whatever specification we want to have for grid batteries, but then that would compromise performance, right? So there's always a trade-off is going to be the lesson of the day.
Yeah, and I think the general theme is batteries designed. There is not one battery for all use cases, and so it's really about defining what those use cases are and designing something specific. And at least for Jungwoo and Richard and I, we think, at least I think a lot about lithium ion type adjacent battery formats, but that's just one type of energy storage device. And so thinking a bit more holistically when it comes to grid and stationary storage is important. But I've definitely double click on Richard's comment about in-field monitoring and diagnostics is a really hot topic and one that there's a lot of area for improvement for sure.
Great. All right, well, we have a few minutes left, so if anyone in the audience has any final questions for our panelists, please don't be shy and drop them into the Q&A here while we still have a few minutes left in the session. But yeah, just thinking kind of starting to wrap up our chat here, just thinking into the future, what are some of the exciting trends kind of in your space in battery development? Doesn't necessarily have to do with intersection with safety, but just kind of where do you see battery industry moving forward? Richard talked about expanding markets into maritime and aviation. Yeah, curious to see kind of your panel's thoughts on the future of batteries and battery deployments.
I think we're all clearly in this industry because we see not just the promise of what this field's done, but the excitement about the innovation happening here. I think sort of the biggest trend that pretty much not just us, everyone's talking about is just the mass scale up of this innovation is going to be pretty much the thing we're going to be talking about for the next decade and how we get there, right? Because it's not just about proving it in one vehicle or one system. It's going to be millions and millions and millions of these units going out there in the field where you need the diagnostics, why you need the inline monitoring, why you need the new chemistries, and why it won't just be one system that rules them all, because every use case will be different.
Yeah, I was going to actually talk about innovation, not in technology per se, but going back to the whole, training and workforce development and right, in order for us to build and deploy, we need people and we need, curriculum that really gets the people who are impacted the most also participating in building and deploying these things.
Andrew, you stole mine. But yeah, I just yeah. Well, I mean, could leave it as enough said, but we'll say that we'll applaud the Commission and the state of California for some of the early efforts into this. One is regarding the C-Terra, which is an effort to provide microgrids and other resilient solutions for tribal communities throughout the state. We're building a big sort of labor roundtable component and technical assistance hub to really, again, bridge those gaps, and so that nobody has to reinvent the wheel. And while not just on the how to deploy and how to build a workforce, but the actual effort is to get workers, get jobs, get knowledge, because that will be a bottleneck at some point, if not already.
And then I'll highlight technologically. I think we're at a point in the industry where the last 10, 15 years, there's been so much money spent on chemistry and materials level innovations. And we are now getting to the point where a lot of companies are reaching the point of first actual deployments. And it's a very interesting time in the industry's history because we have not deployed new technologies actually for a very long time. Lithium ion has been a very slow and incremental step up of capabilities, whereas these new technologies, both at a materials and cell level, from a manufacturing innovation and process perspective, and also from a how do you integrate it into a module and a system and a pack effectively, are all very new concepts. And so there's a ton of innovation that's going on as these new technologies actually get deployed now in real world applications, but also it's one of these, I think, also stressful points for a lot of these technology companies going through their commercial valley of death. And you see the silicon players, you see the lithium metal players. How do they, get a product market fit at the end of the day and really scale to that first market? So definitely an interesting time in the industry's history to see these technologies beginning to have impact, and also some of the challenges that companies inevitably have on their way to scaling.
Yeah, I mean, I definitely get the sense, and kind of echoing this morning's discussion, that really scale is we're kind of on the cusp, right? Where, as you mentioned, Richard, a lot of these technologies spend a long time developing and incubating. We're really on the cusp of how do we get a lot of this out as fast as we can, while at the same time not sacrificing things like safety, right? It's not good to haphazardly scale up, right? If we're cutting corners or we're deploying them kind of recklessly, right? So ensuring that there are those safeguards and those standards and those testing protocols and everything that you all talked about today. But really, yeah, the theme so far has really been about achieving scale quickly. So yeah. Let's see, a couple of final questions here. So we could do just kind of a quick round if anybody has any thoughts. Are there any disruptive technologies on the horizon that could have significant impacts on battery safety that anyone aware of?
I mean, you have two folks sitting in this panel that are working on some pretty exciting stuff.
You mean yourself, Andrew, and your defect analysis?
I would agree. Let's see. Is there any list of battery types that already designates or seem to be more safe than another type? I guess this gets more into the kind of materials or the chemistries part of the batteries.
I think it's a spectrum. So sodium-ion batteries are still at the beginning stages of deployment for grid applications, but many of them are known to be materially quite a lot more thermally stable than any lithium-based chemistry because of the cathode chemistry primarily. And also, on the cathode theme, iron-based chemistries do tend to be more thermally resilient than nickel-based chemistries. That being said, there are also plenty of instances of LFP batteries on grids that have also gotten to thermal runaway. So like this idea of LFP is fundamentally safe is absolutely not true, but they have more thermal resilience. It's for sure.
I do want to echo that. There's never going to be 100% safe battery out there. It is still an energy source. This is all about safer and about mitigation.
Yeah, definitely an important perspective. I guess, it makes sense, right? There's so much focus on increasing energy density for performance and everybody wants range, but I guess that, it comes at a cost of potentially increasing risk. It's really about mitigating those, right? And reducing likelihood. All right, well, we are at time at 2:00. So I want to thank our panelists here for a really engaging discussion, super interesting. I definitely learned a lot. I hope our audience here had some great takeaways from it. So Andrew, Richard, Dan, Jungwoo, thank you so much for your time participating with us today. That does it for day one of the EPIC Symposium. So on behalf of the CEC and the IOUs, all the EPIC administrators, want to thank everybody for tuning in. We do have a second day starting at 9:00 tomorrow with another full program. So please come back and check out the rest of the symposium starting tomorrow. All right, thank you, everybody. Really appreciate it.
Thanks.
Thank you.
Thanks for having me. Thanks, everybody.